Hi everybody, we're group one, and we're going to start by introducing our website. Justin here programmed it with HTML, so I'll let him take it from here.
Okay, so I don't know what to talk about, but there's I guess you put CSS coding in the website, and see, like when you highlight, it has these cool things, but I don't want to click it because it's gonna like blow up. Anyways, so here's our pictures and stuff and how we started our building process, and here's our Prezi. It's stuck in there, but they don't want me to play it because they're scared it might blow up too. They're unreliable. Okay, here you guys go. See, it's here.
Yeah, just zoom up.
Yeah, there you go. All right, so Moni's going to start with an introduction.
Yeah, hello everyone, we're Team Rocket. We worked very hard on this anti-tech project, and today we're going to present it to you. I really want you to know that we worked as a team, and everyone came from, most of us came from different cultures like Turkey, China, and like America. America, and with the combination of different cultures, we did. I believe that we did a perfect job, and our anti-tech project works really good. I'm Moni, by the way.
I'm Justin.
I'm Duncan.
I'm Sachin.
I'm Alan.
I'm Colin.
And this is Team Rocket.
We all end with ends except
This is just a short introduction to this shows that we did it. Like, we managed to do it. And let's start.
Okay, so now I'm going to talk about planning. And planning is the most important part of any project. It's important first to plan, and that involves several steps. We have to plan out the diagram, and that involves people who really understand the material of electrical engineering. We have to plan out the process. How are we going to build this? Who is going to cut wires? Who is going to put them in the circuit? Who is going to make the Prezi? So this involves dividing and conquering, making the most efficient assembly line we can in order to make the most efficient product in the least amount of time. And I believe we did that as well as we possibly could given our limited resources. Also, we have basic principles that we had to cover, electrical engineering, and with that we had specialization within that. Beyond just shaving wires or someone placing in the wires into the circuit board, we knew that we needed someone who could do the Yenka, someone who could program, and someone who could understand and write the circuitry, and then other people who could look on and make sure that the circuitry was good. And we are going to talk about how we implemented this planning throughout the rest of this presentation. So now Justin is going to talk about the circuitry. So this was our preliminary circuit, but we mainly started out with Yenka. So Justin, do you want to talk about Yenka?
maybe. But anyway, how do I keep things?
Arrows. The arrows, the right arrow.
Okay, so this is our Yenka thingamajig, and you can see we set up, well first we start with the planning for the truth table, have all our switches and binary cool coding and stuff, and then we go to the logic statement with our equations from the truth table, and we get this wonderful masterpiece with gates and lights and switches, and it's just cool. Yeah.
So now,
Okay, then after Yenka and the design process, we started constructing stuff. And being what Moni said, a more cultural diverse group, we had a few issues, meaning like especially in measurements, metric and imperial that conflicted quite a bit. There was also conflicting with Z and Z for the switches, but that wasn't as bad. And we worked really hard. Yeah.
Right there. I'm stripping.
So we did work really hard. We teamed up together, we tackled this project, and it showed us that it required a lot of patience, a lot of determination. We needed to persist no matter what obstacle, because there were obstacles, but you had to persist, you had to take your time, and eventually you would get over the obstacles, and things would work out, eventually.
Yeah, so some of the problems we faced, we kind of skimped on the planning a little bit, so we kind of dove right into wiring the circuit before we had really a concrete plan that we could go off of. So we ended up with getting the inverters mixed up with the inputs and outputs, so we, yeah, backwards inverter chips. So we had to take everything out and start all over again, which was proved to be a lot of time. Yeah, and then we built the circuit again, and then we found out that one of the chips had fried, so we had to go back with a voltmeter and replace that. And then another problem we had was wiring, because we pulled so many wires in and out of the breadboard. We had the wires wouldn't stick into the breadboard, so they kept popping out, which was also a nuisance. And then finally we had the switches short-circuiting. So lights would flicker on and off, and it was, yeah, bad. So Ellen here will talk about how we solved those problems.
So after we found our problems, we first try to fix them by rewrite our plan. As you can see, like we make it more clear and concise, so we can more precisely to follow the diagram to track all things. And then we revise our circuit board again. Like we change our burn clips, and then we took out some wires and plug them in again to make sure they connect well. And then we, at last, we let our partner to check all our work to make sure there are no more problems. And in the end, the circuit board like successfully worked. It's good. So we'll have money to introduce the final product.
Yeah, and we want to say that in conclusion, after all the hard work, we finished it and the device was completed. We're going to show you a before-after photo. This is where we started, like with one light, two batteries and the board. But then after all the hard work and passion we showed, this was the final product, like more complex, and it was working. And like, that's all. We want to show
And then now we're going to do a live demonstration of the circuit board.
Alright, so as you can see right now, none of this